Hello dear children. Now in this video we'll be discussing the first application of the potentiometer. There might be many applications for the potentiometer, but for the 12th board purpose this is a very important one. So we'll discuss this in detail. I've not made the diagram, so we'll make the diagram in front of you. So what is the diagram? See, we have a potentiometer wire which is of 400 centimeter long. So we shall not show that wire in 4 different parts, but we shall show them in a form of a straight line. So this is a wire, and beneath this wire there is a scale which is fixed on the wooden table to note down the length, whatever length we want to note down. So we have that scale connected beneath it. So further we have to make the auxiliary circuit. Auxiliary circuit consists of a driver cell. In series with the driver cell we have an ammeter, and in the series of ammeter we have a rheostat, and finally we have a key. Connecting key is also very important, and then the circuit is complete. You can give 2 points or blocks to these 2 points where the wire is connected, because away from this block this wire is made up of copper, but this wire between these 2 points AB, it is made up of an alloy which has a constant uniform resistance. So resistance per unit centimeter of this wire is a constant quantity. Further, resistivity of this wire is very high and its area of cross section remains same. Now what is the principle? If this is the driver cell written as E, then the other 2 cells whose EMFs are to be compared must be connected from this point, meaning all the 3 cells should be connected from this positive point. So this is cell E1, this is cell E2. Now other end of this cell is connected to point 1, is connected to point 2, and a point 3 is left as it is. Now basically these 1, 2, 3 point are two-way keys. Actually what type of two-way keys we have in the lab? So you have page here, 1 screw here and 1 screw here, and this is point 1, this is point 2, this is point 3 which we are discussing here. So cell 1 is connected in between 1 and 3, cell 2 is connected in between 3 and 2. If you will put a key here, then cell 1 will be there in the circuit and cell 2 will be out of the circuit. And if you will remove this key from here and put it here, then cell 2 will be in the circuit and cell 1 will be out of the circuit. Obviously if you will put both the keys, then both the cells will be in the circuit. We are not going to do that thing in any case. So point 3 is connected to a sensitive galvanometer, and the other end is connected to a point which is called jockey, is connected to a metal contact that is called jockey. So what are the working points that we are going to discuss here? We'll study that. First of all, you will put in the key and maintain a constant flow of current through the wire, and then the following connections, the connections that we are watching in the circuit diagram, we will make those connections. And after connecting, first of all, number 1 point 1 will be put the key between points 1 and 3, points 1 and 3, such that cell E1 is in the circuit. Now as you have cell E1 in the circuit, what is the next point that you are going to do? Then move the jockey smoothly over the potentiometer wire and find the null point. Find the null point. Null point, if I remind you, is the point where galvanometer shows no reading. Suppose that point is this. So position of jockey is J1, length between these 2 points is L1. So The AJ1 length that you have found out is L1. Now according to potentiometer principle, E1 must be directly proportional to length. Potential must be directly proportional to length. Now coming to point 3. Now remove key from 1 and 3. Put in 3 and 2. 3 and 2 के बीच में जो gap है, there you are going to put this key. Then what is the next point that you are going to do? Again move the jockey and find null point. Say that null point is J2 and the length is AJ2 is equal to L2. So according to potentiometer principle, if this is equation 1, E2 must be proportional to L2, equation number 2. Now comparing 1 and 2, we get E1 by E2 is equal to L1 by L2. So children, this is the final relation that show you the comparison of EMFs of two cells, and this comparison can be carried out by calculating the null point lengths using the potentiometer.